This is section 12.5, solving compound inequalities. Okay, so the first thing we've got here is write x is less than 0 and x is greater than or equal to negative 3 as a compound inequality without using an and. So basically what we want to do here is get rid of this and combine these together all as one. So what I usually do is I take whatever the variable is, so like x in this case, and then usually I go in like numerical order, so I would put like the smaller number over here, bigger number over here. And then I'd go, okay, my number x has to be less than 0, so I'd be wanting to go that way, eating towards the 0 still. And then here I want to be greater than or equal to negative 3, so I want to be eating towards the x here and equal to. Okay, so you want to keep eating towards the same things and kind of combine that together all as one. Okay. You could go the other way with this if you wanted to and swap your signs around and put the 0 at the beginning and the negative 3 at the end, but usually this is the form that you typically see. Next thing we're going to talk about here is ones that are intersection problems, or what we call like and problems, where both of your solutions are going to be the same. So intersection, what they're kind of talking about is like in a Venn diagram, the intersection of those two circles, the middle part there would be things that work for both of those. So it would work for whatever this is, and it would work for whatever this is. So like one of these circles in this case would be like x is greater than negative 2, and then the other circle would be x is less than 3, and what we want to graph or find is the ones that would be in the middle of that would work with both groups. So one thing you can do here is you can think about these separately. So I've got x is greater than negative 2 and x is less than 3. So when I do my numbers here, I'm going to do them as negative 2 and 3 instead of like negative 2, positive 2, just because I'm going to be comparing all of these graphs together. I do usually throw a 0 in there just to make a reference point, and I'm going to make each of these exactly the same. And once you get the hang of this, you don't have to graph 3 graphs each time, you just have to do it once. But to kind of get you started here to show you what's going on, I'm going to do 3. Okay, so for the first one here, what I've got going is I'm going to graph x is greater than negative 2. So just like I've graphed before, this is going to be an open circle because it doesn't have the equal to sign underneath. So open circle at negative 2, and then I want everything that's bigger than negative 2. So I shade off to the right. Okay, so that's one of them. The other one I'm going to graph here is x is less than 3. So again, open circle because it's not equal to. And now I want numbers that are smaller than 3. Going that way. And then for the last one, what we're doing is we're combining those two graphs. So you want to see what numbers are in this graph and also in this graph. So this one is going to be negative 2 is less than x, less than 3. So basically they just took these two individually, combined them together all as one. And now when we graph it, we're taking the spots where it crosses or it intersects. So like here, if I kind of follow down, well, it's both blue and red in between negative 2 and 3. So what I'm going to do is I have open circles for both of those still. And I want numbers that are bigger than negative 2, so I'm going to be going this way. And then I want numbers that are less than 3, so going that way. So the spot that both of them are is what I shade. Okay, so it's basically just a chunk of line in the middle there that would be the intersection of those two. Okay, so let's look at this next one here. So we've got 10 is less than w is less than or equal to 65. Okay, so again, I don't really have to do all the numbers here, making tick marks up to 65. I'm just going to do 0, 10, and then 65, and I slid that down a little bit because 0 and 10 are 10 spaces away, and then 10 and 65 are a lot more spaces than that away, so that's why I kind of broke that up a little bit. And I'm just going to use the same numbers here. Okay, so first one I'm going to graph this part that has the blue. I'm going to graph the part that has the 10. So I've got w is greater than 10. So I just flipped it around, but I'm just doing this part here. I just flipped the w to the beginning because that's typically how I like it, but you don't have to do that. You could have left it as 10 is less than W. Either way, that's the same thing. So when I go to graph that, it's going to be an open circle on 10, and then I want things that are bigger than 10 because I'm eating towards the W. So I'm going to be shading off to the right here. Okay, and then the second one, this is where I'm dealing with my 65, so W less than or equal to 65. So this time I'm going to have a filled in circle because it's equal to 165, and then I want everything that's smaller than 65 to be shading that way. My arrow in there. And then again here for the last one, this is where I combine the two graphs. So 10 is less than W, less than or equal to 65. So here I basically have an open circle on my 10, closed circle on my 65 because it's equal to for that one, just the same as it was for those graphs. And then I want numbers that are bigger than 10, so going off that way, and numbers that are smaller than 65 that way, and I want where those intersect or cross each other. Oops. So I shade in the middle of those. Okay. All right. Next one here, we have to do a little bit of solving. So we've got -6 is less than or equal to x minus 3, less than or equal to -1. Okay, so what we do on a problem like this is we split this into two separate groups, okay? And when we split into two separate groups, this middle part here, treat that as a chunk. That goes with both groups. So I would have one that's -x is less than or equal to x minus 3. Then I take that same middle chunk, x minus 3, and do that with a separate equation here. So now I've got x minus 3 less than or equal to -1. So just taking those two halves there, breaking them up, keeping the middle exactly the same for both of the groups. Okay, and then I just solve these like an equation. So to get rid of subtracting 3, I would add 3 to each side. So that would be -3 less than or equal to x. And then here, same thing, add 3 to each side. So x is less than or equal to, that would be 2. Okay, so then those are my two answers here. What I can do, since this is an and one here, what I can do is I can combine these together to be one answer if I wanted to. So -3 less than or equal to x is less than or equal to 2. So either one of those, basically you're just pulling those together at the end to make them into one inequality. And then what we do is we graph it just like we did before. Now, like I said, the better you get at these, you don't have to do 3 graphs out. What I usually do is I'll take those numbers there, so like I've got -3, 0, and +2. I know it's going to be closed circles on both of them, so I'm going to have filled in there, filled in there. Now with this one here, I want all numbers that are bigger or equal to -3, so that would be going that way. And I just draw a little arrow instead of doing like a full graph like I did before, just a little arrow. And then same thing here, these are numbers that are smaller or equal to 2, so that would be going that way. And then I want the intersection of those, so basically the middle. Okay, so instead of doing 3 out, you could just do like little arrows there, kind of like I did, and then shade the parts that match up. Okay, so that's all of our intersection ones. Now we're going to go to union ones. So what union means, if we go back to our Venn diagram here, union is everything that's in this group as well as everything that's in this group. So basically all of your possible options are what your union is. And they'll say the word or when you're doing union ones like this. Okay, so let me kind of show you the difference here. So with this first one, we've got graph the solutions, and we've got x is greater than or equal to 7, or x is less than 3. So again, once you get the hang of this, you don't have to do, you know, three graphs out here, but I'll just kind of show you for the purpose of learning it. Oops, I should do these first. So I've got my two numbers there, 3 and 7. So I'll throw some zeros on there, 3, 7, 0, 3, 7. Okay, so the first one I'm going to graph is x is greater than or equal to 7. So that would be a closed circle on 7, because it's equal to, and then I want numbers that are bigger than 7. So I'm going to shade off to the right. And then the next one there, I've got x is less than 3, so open circle on 3 because it's not equal to. And then I want numbers that are smaller than 3. Okay, so now what's different about this one when I go to do my last graph here is you can't really combine these to be one inequality without a word in there. You have to keep them separate with the or in between. And ones you can combine together like we did on the previous page, but these ones you just leave separate with the or in between. And then when you graph them, you want things that are in either one of the groups, so it could either be in the red graph, so closed on 7 going to the right, or it could also be on the blue graph, open on 3 and going to the left. Okay, it could be, the answer here could be either one of those things. The only things that wouldn't work would be numbers in the middle there, like 5 would be in the middle. So 5 wouldn't be greater than or equal to 7, and it also wouldn't be less than 3, so that wouldn't work. Same with 4, 6, that kind of thing. Neither of those, and none of those would work for that because they, are in that middle part which isn't shaded by anything. Okay. Next here we've got some more solve ones. So we've got 2/3 x is greater than 4 and -5x is less than 20. Okay, so 2/3 x greater than 4. Our other one, and these are just being split by the or, so you don't really have to, break it up like we did with the previous one. And then this one is -5x is less than 20. Okay, so let's start with this fraction one here. So to get rid of multiplying by a fraction, we multiply by the reciprocal. So we're going to multiply by 3/2 on each side. Because then what will happen is the 3's are diagonal, so they'll go away. 2's are diagonal, those go away, so I'm just left with x is greater than, and then here I'd probably put my 4/1 to turn it to a fraction. Then again, look at my diagonal way to see if I can reduce, so 2 would reduce to 1. 4, if I pull a 2 out of that, I am down to 2. And then from there, I take top times top, so 2 times 3 is 6. Bottom times bottom would be 1 times 1, so 6/1 is the same as 6. That's one of my answers. Or my other answer here, to get rid of multiplying by -5, I'm going to divide by -5 on each side. So x, and then remember, when we take and divide by a negative or multiply by a negative, our sign is going to switch around. And then if I did 20 divided by -5, that would be -4. So those would be my two answers. So it's either this or it's this. Okay, so then again here I could graph those out. So my first one, I've got x is greater than 6. So I should do my little numbers here. So I've got -4, 0, 6. Okay, so the first one, x is greater than 6, so it'd be an open circle on 6. And then we want anything that is bigger than 6, so I'm going to be shading to the right. And then the next one, we've got x is greater than -4. So open circle on -4, and we want bigger than -4, so shading to the right. Okay, so now for this one, what they want is it can either be in this group or it can be in this group. So x is greater than 6 or x is greater than -4. Well, if you think about it, isn't every number that's greater than 6 also greater than -4? So every number that would be in this red shaded part here going this way forever would also be in this blue shaded part here going forever. So really, when you write this, all of the red ones are actually going to fit in the blue. So really, this is the same as the graph of x is greater than -4. So if I do this here, open circle on -4, going to the right forever, that would fit everything in this graph and also everything in this graph. So sometimes your answer could be written like that, where it's got an or in between, or it might be a situation where both of your graphs will actually match up, and this one doesn't really mean anything because everything that's bigger than -4 is also bigger than 6. Okay? Alright, so that is it for notes. So your book page assignment is 527, 18 to 54 even.